Hello, my name is Steffi, and I'm a UX mentor here at STEMaway. I am actually a graduate of the STEMaway program back in 2021, so the second year of interns. And AI code assistance, a very wonderful tool, a very useful tool, as we have seen from Colin and Dilshan. However, you can have all these wonderful tools, but if you can't really use them properly, then what's the point of having them? So my job as a user experience designer in research is to find the pain points. So why are these tools maybe not working to the best of their ability? Why are they not actually helping people get all this code done, help find all this data, etc., and then find ways to improve it? So how do we do that? Well, you have to actually talk to the people who use these tools. So I'm going to be doing a little mock interview with Colin and Dilshan. So first step is just getting basic information, which we already got from their introductions. So we've learned the tools that they use and also what they use them for. So now let's dig a little deeper. So I am just going to start off with Colin. So do you feel like these code assistants have increased your productivity, and how have they done so?
I don't think they've increased my productivity. So I think in general, I see some value in some of the snippets that have been generated for incredibly narrow tasks. So taking a step back in my day-to-day workflow, because I'm in a research environment, by design, right, by desire, what we produce should be slightly innovative, right? It should be code that doesn't exist somewhere. So often I find myself relying on a set of functions that I've written that do very basic things, right? Where you're fitting a logistic regression and you're picking the optimal threshold. That's exactly the kind of task that is perfectly presented through these tools. But I actually already have a library of these things that I've been accumulating myself before generative AI became as popular as it was. So for most of my other workflows when I'm writing code, I find that the code is too abstract and too complex. Too many operations are being chained together to get useful suggestions out of things like GitHub Copilot. But that's my personal day-to-day experience thus far.
So you're, just to spit that back and just make sure I get it, you're saying that it just helps you maybe solidify what you already have, just confirm what you already have, but in terms of maybe making any huge leaps or such, not as much as maybe people would think. Is that what you're saying?
Yeah, exactly. I think that it's more of a distraction than it is an addition in my productivity, because I am somebody that's very specific about the type of IDE, the environment, the visual patterns of what I'm seeing. And so to me, if I'm going to reject or ignore, let's say 95% of suggestions that are popping up, it's really just a distraction. It's actually detrimental to my workflow. So there are those 5%, 10% cases where there's a utility, let's say fitting a model, or as we just saw with Dilshan, web scraping. I always know that web scraping is important for getting data, but it's one of those things that's tough to do. You know, oftentimes it's one of the more laborious aspects of building your data set. So that's a situation where I might leap to try and use these tools to get a web scraper in place, because even though it's a process I do a lot, I actually don't have a rich set of utilities that handle that already. So in my work, yeah, if it's something that I've addressed before, odds are I've already built that piece of repurposable code. And if I haven't ever seen it before, odds are things like Copilot actually can't address the problem yet. And I think that my attitude will change over time, obviously, as the corpus of code that is going into these things is increasing and expanding. And there become opportunities where you could fine tune this on your own code, right? So I could easily see it becoming useful as it becomes a little bit more customized to the type of code that I write. But as it stands right now, that's my overall sentiment.
Interesting. Okay. I was not expecting that, but I like that answer. Dilshan, not sure if you use these same types of assistants. If you do, great. But if not, do you feel the same kind of sentiment, or do you feel that maybe it is more beneficial to the kind of work you do?
Okay, so since I'm a student, a lot of the stuff I do isn't too difficult and people have done before. So tools like ChatGPT or GitHub Copilot, they really help in the process of developing code for me, because I'm sure Colin is working on more complex things which are a little bit more custom. But for me, I usually work on stuff which is more basic, and Copilot can help me speed up the process of finding out how to do some stuff. And ChatGPT is really useful when I'm trying to search for a solution. I'll often end up in places where like they give me the code, but I don't know what it does. And ChatGPT is really good at explaining that for me. And I but usually use Copilot a lot for just doing basic stuff, which I might need help with.
And if I could just build on top of Dilshan's answer there.
Sure.
So I love that answer, Dilshan. And I also think you're doing some very complex things, having seen the work that you've put out. But what I would try and make a distinction between is complexity and abstraction in terms of the chain of operations that has to go into code that's being generated. So oftentimes something can be complex and difficult to understand, but succinct to write in code. It only requires a singular function, a singular set of operations. Often what I do is not complex in that it's not necessarily hard to understand what I'm looking for. It just requires a chain of operations, 7, 8, 9, 10 steps long. And that's actually where we see a lot of these automated generative AI assistants struggle, is it's not that, you know, we're asking it to invent something brand new and solve some scientific problem, but when you start requesting or you have data pipelines that have so many intertwined pieces, and the things that you're trying to type require many compound operations, I think that's where things get challenging. And like Dilshan mentioned, if you're a student, this is not a big deal. This is actually a good thing because you can focus on small atomic operations and learn what single functions do. As you begin to work in the real world, you become responsible for chains of operations that might go very deep, even though any given unit of that chain is not that hard to understand. You're basically composing all of these things that we saw Dilshan do in real time. And by the way, that's very difficult to do. Everybody here knows that. And if you don't know that yet, you'll learn soon. Live demoing code is very difficult. So as we saw in real time, right, we kind of saw you go back and forth, build up each unit of operation, and it's stringing them together where the complexity actually lay, in my opinion. So I just wanted to add on top of what Dilshan just said.
And I just want to add along that line too, Colin, is I found that as a pipeline that you said, to set up the environment, I don't get enough help from these tools. So Steffi, I know this is a kind of a side to it, but it's related to the question as to how useful the productivity part of it. But I'm talking in terms of a full stack, which is very different from both Colin and Dilshan. I've never done full stack before. Environment, I struggle even with ChatGPT help. But once I have the environment in there, it's remarkable the amount of code that it can generate. But if you could also mention, Colin, a little bit about, now, Steffi asked you a question, and some of the questions in the surveys will be yes or no, but we got very detailed answers from you and Dilshan. How can machine learning help in analyzing these kind of questions? A bit of a segue, but if you could just give your thoughts on that.
Yeah, absolutely. So as you alluded to, there are differing degrees of complexity and abstraction in the way data can be represented, right? So I would say the most basic variable you can have is something that's binary, right? 0, 1. It's the smallest unit of information you can convey. And you can get a lot of information out of whether something is present or not, or happened or did not happen. So those are the simpler variables. Then there might be categorical variables where you could take on several different values. For example, the type of education that somebody has. So I have a bachelor's in science, right? So that might be one category of education, whereas somebody with a PhD, or if Dilshan doesn't yet have his bachelor's, he may have high school as his education. That's an example of a categorical variable. Yet it's still simplified. It's still structured from a computational perspective. Where things get challenging is what you're alluding to when you have unstructured data. So we can imagine a transcript of every word I'm saying right now in real time. And like you're saying, that contains and imparts a serious degree of information about what I feel in regards to code assistance. The question is, how do we take this unstructured mess and induce some kind of structure? And that's exactly where modern machine learning techniques, actually the very same ones that are powering things like generative code assistance, can assist with. So the idea is that language can actually be encoded as numbers. There's a sort of arithmetic or geometry to the way we can represent language. And the way this happens is by, instead of saying, here's the transcript, we turn each word into a list of numbers that is some abstraction, some sort of aggregation of the meaning behind those words. And we don't have enough time, as you know, in this call to talk about the operations that produce that meaning in numerical form, but that will be a webinar that I give in terms of what is ChatGPT doing to be so effective. And as a sneak preview, what it's actually doing is it's ascribing numeric properties to textual prompts and then continuing those prompts by asking what number sequences should follow what the textual prompts were. And so modern natural language processing is this continual exercise in trying to take unstructured text and turn it into lists of numbers, where those lists of numbers have inherent relationships to each other. And what we can do with those lists of numbers is, again, induce some sort of geometry. So we can ask, when I'm talking about my experience, how similar is that transcript to Dilshan's transcript? So we could take each of those, try and encode each of those and say, what is the similarity there? We touched upon very similar themes, right? We're talking about our experiences, yet I'm coming from a different perspective as Dilshan. He mentioned being a student. He mentioned the utility in learning the individual pieces of functionality. That's not where my focus is on using these tools or rejecting these tools. And we hear that come out in the different words that I spoke versus Dilshan's. And so if we had two new people give their take, one that's a data scientist working at a research institution, presumably their transcript would be encoded in similar fashion to mine. And if we had another student that was a high school star that is amazing at programming, learning these things, their transcript would be very similar to Dilshan's. And that's the goal, is what mathematical procedure or recipe is going to allow those transcripts to be encoded or represented with those numbers that create this property. And so that's where we can start to get into downstream machine learning, is we can say, we have all of these ways now of representing the language, representing words and phrases and their context and meaning. And then we can ask, who is similar? Who is actually describing similar linguistic patterns? And we can combine that with the structured piece, where we might have educational background as a categorical variable. And we can look at the relationship there. Are there clusters of educational backgrounds? Is it always true that the transcript of somebody's sort of thought process as they talk through these mock interviews cluster similarly to those with similar educational background? In some cases, that's what I would hypothesize. In other cases, maybe not so much. So that's really where the secret lay, is in reality, right? When you start working in these fields, that's often the kind of question you have to grapple with, is you have structured data, unstructured data, and somebody's asking you, what are the relationships here, right? What allows you to understand the information that you have at hand, and why is it valuable? And I would wager it's very valuable to understand, is there a relationship between the overall sentiment and way we describe our relationship with code assistants and your educational background? And so that, to me, is really where we want to take this, is we don't want to ignore all of the rich information that's conveyed as I speak. We want to actually leverage that, create some sort of numerical representation, and integrate that with all of the other data that we would be collecting in a much more structured, straightforward fashion.